Hey guys, Mr. Backerberg here. In this video we're going to look at using scientific notation. So scientific notation gives us a way of writing out very, very large or very, very small numbers in kind of a succinct manner. So when something is written in scientific notation, it looks like some c value times 10 being raised to the power of m. Now there's two things that need to be true here. That c value needs to be a number between 1 and 10, and m needs to be some sort of integer whole number. So first let's look at a really big number, something like the distance from the Earth to the Sun, which is about 93 million miles. Right now, as this number is written, the decimal point would be after that last zero. So what we want to do is work on converting this number into scientific notation by sliding that decimal so that we end up with a c value that's somewhere between 1 and 10. So I'm going to take this decimal and I'm going to slide it all the way over here so that we end up with 9.3. Okay, so we have to count up the number of spaces that we're moving our decimal. So that would be 1, 2, 3, 4, 5, 6, 7 spaces. So we get that 9.3. That's our c value. Then the 7, since we move this decimal point 7 spaces, the 7 becomes the power that we put on that 10. So 93 million is the same as 9.3 times 10 to the 7th power. Now if we wanted to deal with a really small number, something like the mass of an oxygen molecule, okay, so that number that I just wrote down represents the mass of an oxygen molecule. Again, we're going to try to rewrite this in scientific notation by sliding the decimal. This time we're going to have to slide the decimal all the way over to the right so that we get our c value between 1 and 10. And we're going to count the number of spaces along the way. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 spaces. When we do that, our new number becomes 5.4 times 10, and then we use that number of spaces. We said it was 23 spaces, so we're going to put a 23 on the 10, but since we were moving the decimal to the right, we need to make this power negative. So it's 5.4 times 10 to the negative 23rd. So in this example, we're going to look at converting some numbers back and forth between scientific notation and decimal notation. In the first one, we're given a number written in scientific notation, 2.375 times 10 to the 8th, and we're going to take that and write it in its decimal form. So 2.375. Now this 8 power means that this number is going to be getting bigger since it's a positive power, so we need to slide the decimal point 8 spaces. So we go 1, 2, 3. Now we've ran out of room here, so what I'm going to do is fill in some zeros. So we're at 3, 4, 5, 6, 7, 8. So we've slid the decimal 8 spaces. So that gives us the number 237,500,000. Now in the second example, we've got a small decimal that's written out in decimal form, and we're going to take it and convert it into scientific notation. So here we're going to slide the decimal so that it ends up between our non-zero numbers. So we're going to have 3.49. Now we need to figure out how many spaces we moved that decimal. So if we count them up, 1, 2, 3, 4, 5, 6, 7 spaces. So we're going to have 10. Because we started with a small decimal number, that means we've got a negative power. So it's going to be 10 to the negative 7th power. In this example, we're going to look at using scientific notation to help us simplify down this fraction involving some larger numbers. So I'm going to start by looking at the 360,000. We're going to rewrite that in scientific notation. So we have to figure out how many spaces to move the decimal. So it looks like 1, 2, 3, 4, 5 spaces. So we can rewrite that as 3.6 times 10 to the 5th. If we look at this big long number on the end here, 4,500,000,000, counting up the number of spaces there so that we can rewrite that one in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So we can rewrite that as 4.5 times 10 to the 9th. And then on bottom, we've got 18,000, 1, 2, 3, 4 spaces to move the decimal there. So we get 1.8 times 10 to the 4th. So now what I'm going to do here is rearrange things a little bit so that we're dealing sort of with like terms. So I'm going to take all of the numbers that are out in front and regroup them as one fraction. So it's going to be 3.6 on top times 4.5 on top, and then our 1.8 is going to be on bottom. And then I'm also going to regroup these tens with powers on them so that we can use some properties of exponents there. So we're going to have the 10 to the 5th on top times the 10 to the 9th on top, and on bottom we're going to have the 10 to the 4th. On top, when we're multiplying things together with like bases, we add those powers. So 10 to the 5th times 10 to the 9th would be 10 to the 14th. And on bottom we've got that 10 to the 4th. And if we're taking like bases and dividing them, we subtract those powers. So that becomes 10 to the 10th power. Now if we're looking in the front here with this 3.6 times 4.5 divided by 1.8, if we were to type that into our calculator, we'd get 9. So all of this simplifies down to 9 times 10 to the 10th power using our scientific notation. If we were to rewrite that in decimal form, we would have to take our 9 and slide the decimal 10 spaces to the right. Now there's no numbers here, so I'm going to fill in a bunch of zeros. So we take the decimal and we start sliding it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that number ends up being 90 billion. That's going to be it for this video. Thanks for watching.